So in order to create a NURBS surface from this mesh, there might be several ways to do this, but the way that I'm going to do it is I'm going to create a grid of points that are flat, either above or below the mesh, and then I'm going to project those points onto the mesh so that they have varying z elevation, and then I'm going to use those varied points to produce a surface from a grid of points. So the first thing I'm going to want to do is set up the grid of points. So if you were to go into your top view, my top view, for instance, is not quite orthogonal to the screen. It's sort of at a diagonal, and that's just a result of the site's orientation and the way this geometry came to me from GIS. But I am going to want to create a rectangle that my grid of points can fit into. And so what I'm going to do is in Rhino, I'm going to draw a polyline along one corner, along one edge of my site. I'm just going to kind of drag that out. I'm going to do my best to eyeball to make it aligned with that edge. And then I want to create a grid, so I want to rotate this curve so that it is 90 degrees from this one. So I'm going to make a copy. I'm going to copy it in place, and then I'm going to rotate it. I'm going to rotate it from this bottom corner here, and I'm going to rotate it -90. So now I have two curves. This newest curve that I make is going to represent the x dimension of my site, and this first curve that I made is going to represent the y dimension of the site. And I'm going to try to offset each of these curves to try to make a rectangle. And so I'm going to use the offset tool in Rhino. I'm going to try to find a number that allows me to offset this curve, and so that I can make a rectangle which fits entirely inside of the mesh that I have. So I'm going to find a dimension which I happen to know is 2,250 inches. So I can offset like so, and I'm going to offset the other side also about 2,000 inches. Depending on your site, if you're using my source file, then these numbers would also work for you. If you're using your own site, you're going to need to find a different x and y dimension. And then I'm just going to sort of trim these curves so I don't have any overhanging. Okay, so now I have a rectangle which fits entirely inside of my mesh, except that's not exactly true. I have a little bit of overhang there, which I want to try to avoid. If you do have some overhang, it might cause you some problems later on. So I'm actually just going to move this rectangle over a little bit, like so that the rectangle fits entirely inside. And so this rectangle will be the outer limit of my new NURBS surface. So if there is anything that you're upset about missing, like if you really need this piece of the site, you would want to adjust this so that the rectangle picked up that area. Same is true for over here. Just so happens that on my site, I'm not really interested in this part of it, and so I'm mostly focused up here, and so I can afford to get rid of this stuff. So now that we have some site boundaries set up, we can use these curves in order to create our grid of points. So similar to how we started in the very beginning, I'm going to double click into the canvas and ask for a curve component, and I'm going to use that curve to link to my this y dimension. What I said was the y dimension of my site. So I'm going to right click, and this time I'm going to say set one curve, which sends me over to Rhino. I'm going to pick that y dimension, and then I can see that it's linked itself to the Rhino file, and I'm going to do that again for the X dimension. So I'm going to double click into the canvas, ask again for a curve, and I'm going to right click on that component, set one curve. I'm going to pick the X dimension. And the reason why I'm creating these two curves, one for the Y and one for the X, is because I'm going to use them to create a line, I'm going to use them to create a plane, which is oriented to my site. So I'm going to double click and ask for a plane, and there are several different types of planes. The type that I want is called a line plane. So that didn't bring it up for me, so I'm going to try again. I'll double click and say line. This is the one that I want, the one that says line plus line, create a plane from two line segments. So I can bring the, this was the X. I'm going to bring the X into the A and the Y into the B. And just so that that's a little bit clearer, I'm going to go ahead and label these. By default, they're called curve, which is the type of component that it is. But if you right click up where it says curve, I can change this to say X. So I'm just going to type in X and say enter, and then I'll do the same for the Y, just so I can remember. And then I have a curve plane there, or a line plane. So from there, I'm going to deconstruct this plane, and I'll tell you why later. Deconstruct plane all the way at the top. If I put the output from my line plane into the input of the deconstruct plane, that gives me an origin point. So this origin point at the place where the X and Y intersect, and it also gives me a series of directions, a direction in the, or a vector in the X direction, a vector in the Y direction, and a vector in the Z direction. And I'll be able to use those vectors down the road to help build other things. So let's create the grid of points that we'll use to project at the mesh and then to create our NURB surface. I'm going to create that grid of points by first making a rectangular grid. I'm going to double click into the canvas and ask for a rectangular grid. It's this one that has a grid of points and it says rectangular. It's a two-dimensional grid. If you hover over the inputs, you can see that the first thing it's asking for is a plane, a base plane grid, and this is why we created this line plane. It wants to know how to orient this grid of points, and the plane will show it how to do that. So I'm going to take the output from the line plane, and I'm going to plug that into the plane input of the rectangular grid. And you can see that it has already made a rectangular grid for me. It starts at the origin of my line plane, and it's oriented to my site. So the other components here are the size of the grid cell. So this is a rectangular grid, so it's got if I hover over the SX input, I can see that the size of the grid cell in the X direction is 1, and the size of the grid cell in the Y direction is 2. Further down, the XX input is called extent. This is the number of cells. So I have 10 cells in the X direction, and I have 5 cells in the Y direction. So I can adjust these. I can adjust them with a slider if I want to. And just to demonstrate that, I'm going to double click in the canvas and type in 100. Again, that is going to give me a number slider that goes from 0 to 100. It's stopping only at whole numbers. So I can plug that into the SX, and you can see that it's created cells in the X direction that are 100 units long. And I can adjust that slider to change that dimension. So we're going to want to set up our rectangular grid so that it is contingent on the size of our site. So instead of plugging in a size directly into the SX, I'm going to use the dimension of our site and then divide that by some number. similar to how we did when we rebuilt our curves. So I'm gonna I know that my site is 2000 by 2250, so I'm gonna create two panels which include those numbers. So a panel is sort of like a post-it note. It can hold values. So I'm going to double click in the canvas and ask for a panel. And I'm going to double click in that panel and I'm going to type in my X direction, so 2000. And I will repeat that for the Y dimension. So I can copy this, Control C, Control V, and I can double click in the panel and type in my Y dimension. So I'm going to set my slider as the size in both the X and the Y. So I'll also plug the slider into the Y. So now I have 25 unit by 25 unit grid cells, but I want to make sure that the grid fills the site exactly. So I'm going to in both of these, I'm going to divide the X dimension by the size of each grid cell, which would give me an extent in the X direction. So I'm going to get a divisor, a division component, excuse me, and I'm going to put the X dimension into the A and the size of each grid cell into the B, which should leave me with the X extent. So if I zoom out here and I select on the grid so that I can see it, I should have a grid that fills my site boundary now, at least in the X direction. And so I can repeat that for the Y direction. I'm going to Control C, Control V to get a second division component. On this component, I still want to have the size of each grid cell in the B input, but I want to replace the A input with the Y dimension of my site. And then I can insert the result of that division into the extent Y. And again, if I select the grid cell in Grasshopper, it'll turn it green so I can take a look at it. And I can see that I have a grid, rectangular grid that fits exactly into my site boundary. And we'll use that rectangular grid in order to create a grid of points that we can then project onto the mesh. So the rectangular grid, if you take a look at the outputs, it has two. The first one is called cells, so that's each individual rectangular cell inside of the grid. And it also has points. And even though we're looking for points, we don't actually want to use these points, and that's because there's some redundancy in these points. These points are in sets of 4, so each grid cell has 4 points, 0, 1, 2, 3, etc. For each grid cell. And so that means that on every corner there's a duplicate set of points. So we don't want a set of points with duplicates in it. That may cause some problems for us down the road. So instead I need another way of creating a grid of points. And I think the best way to do that is to use what's called the area component. So if I double click in the canvas and I type in area, that gives me a component that's intended to measure the area of each of these grid cells if I plug this in. But it also, as a byproduct, it shows us the centroid, or if you're familiar with your structures, the center of gravity of each of these grid cells, which happens to be a nice center point with no redundancy. So I'm going to take the cells that are an output from the rectangular grid, and I'm going to plug that into the geometry input of the area component. And Grasshopper might need to think a little bit because there are a lot of cells. That's okay. It should probably bounce back. Okay, so now we have a series of centroids, one on every grid cell. So I'm going to take a look at this in a perspective view. And I can see that my mesh is above my grid of points. The next step here is that I'm going to want to project my grid of centroids up in the z direction at my mesh. And so I'm going to use a tool that's called Project Point. I'll double click in the canvas, Project Point. So I'll grab that one, and if I take a look at the inputs, I'm looking for the point to project, which is my series of centroids. So I'm going to grab the C output of the area component, and I'm going to plug it into the P input of the project component. It's also looking for a direction. So it has a default. If you hover over the D and take a look, it says it's projecting to the 0, 0, -1. So that's telling you it's going to project 0 in the X direction, 0 in the Y direction, and -1 in the Z. So that's going to be projecting straight down. But I want my points to project straight up. It's possible that for you, if you're using your own site, that just as a matter of how your site contours came in, that your grid and so your centroids are going to be above your mesh, in which case you would already be projecting at the mesh, and that would be great. But I need to project up. So one way to do that would be to go back to my deconstruct plane, where I have an X vector, a Y vector, and a Z vector for my site, and go ahead and use the Z vector as the direction. So I'm going to drag the Z output, and I'm going to plug it into the direction input of my project component, and so that should, if I hover over now, that should change it to 0, 0, +1, so projecting up. And then the last thing I need here to make this work is to tell it the geometry that I want to project onto, or tell the points where to stop. And so what I want to use there is my Delaunay mesh. So let's grab the output from the mesh, and we'll drag that into the geometry input of the project component. And it may need to think a while. Mine was pretty quick, but I should now see a replica of all my centroids, but they're on the mesh. So just so I can see that a little bit better, I'm going to go ahead and unpreview my area component. So that takes off the points below. And I can also maybe unpreview my rebuild curves. Go ahead and select my projected points so I can take a look at them, and I can see that they're all sitting nicely on the mesh. So if I go to the top view, I just want to double check and make sure. Sometimes if your grid was a little bit bigger than the mesh, you might end up with one of these points that didn't hit the mesh when it was projecting. So you don't have, not all of your points made it onto the mesh, and that's going to cause you some problems in the next step. So right at this point you want to double check, make sure that you don't have any overhanging areas, and if you do, what I would do is go back and move your original curves in Rhino. I would go back and adjust these original site boundary curves in Rhino so that you don't have any overhanging. Another way to fix it would be to adjust your site dimension here. So I could take this from 2000 down to 1990, for instance, to try to shrink the overall size of the site. Okay, so now that we have these projected points, we have only one more step in order to make this NURBS surface, and that is to use this grid of points to create a surface from points. So I'm going to double click in the canvas and type in surface from points. So I'm going to grab that. It should have 3 inputs. The first one is the points, which we'll get from our project component, and then the next thing is the U count. So similar to the way that your Rhino window has X and Y dimensions, which are sort of global to the modeling environment, each surface has a series of local coordinates, which are similar to X and Y, but they're called U and V to differentiate them from your X and Y dimensions. So in order for Grasshopper to understand how to use this grid of points, it asks you for the U the number of points in the u direction. And then from there it can understand through dividing how many points there should be in the v direction. So fortunately we made this grid of points, so we can easily tell what the dimension in the u direction is. So what I'm going to do is grab my x direction, which is the result of this division that we did a while back. That is also the u dimension of the site, so I'm going to go ahead and grab that, and I'm going to plug it into the u. That way we're all set up. And I'm also going to put the project into the P input of the surface grid. But before I do that, this is a fairly memory intensive act, and if anything is wrong, it could send your Grasshopper file into a long time of thinking, so this would be a good time to save your file. So even if your Rhino file hasn't changed or it's saved, we should go ahead and save both our Grasshopper and our Rhino file. Which is important to note that when you're working in Grasshopper, there is a separate Grasshopper file from your Rhino file. So I'm just going to go to File, go to Save Document, and give this a name, something like Shamisol Topo. So now that I know if something goes wrong with this next task, I can always just shut it down and get it back. I'm also going to save my Rhino file here. Just in case. Okay, with that all done, I'm going to take the points output of my project component, and I'm going to plug that into the points input of my surface grid component. And similar to when we made the mesh, we get a red alert on our surface grid, and we're not getting that surface yet. And again, this is for the same reason that we had problems with the mesh. The points that are coming in have a hierarchy. They were produced from a grid, so they're organized into rows and columns of points. And the surface grid, that sort of organization is confusing the surface grid. The surface grid instead wants to use the u value and then understand its own organization of the points from there. So we're going to want to flatten the organization of those points. So I'm going to, similar to what we did on the mesh, I'm going to right click on the points input and I'm going to flatten. And that seems to have fixed it, although it's thinking a little bit. I'm going to go back to a perspective view. And there's a bunch of stuff on here, so I'm just going to turn a few things off. I'll turn off everything actually except for the surface grid, so I'll turn off my projected points, and now I can turn off the Delaunay mesh and the mesh edges, and so there I have a nice smooth NURBS surface. And maybe I'll kind of turn back on my topography again, which would enable me to take a look and make sure that my NURBS surface was doing a good job of approximating my original contours. If it wasn't, if you have a sort of low resolution NURBS surface and you were starting to lose information, so it wasn't hugging tightly to the contours, you can also always go back and increase the resolution of your NURBS surface, and you would do that here. So the larger the grid cell, the lower the resolution. You can start to think of this similar to the way you think about maybe points per inch in Photoshop. If I have a 2000 by 2250 image and I have sort of 80 dots per inch, that's kind of like resolution. So I could reduce the distance between each pixel, for instance, here, which would increase my dots per inch. So in effect, this is kind of like the resolution of your surface. So you know, you want it to be as close to the contours as possible without making a file so big that you can't really work in it. So I would kind of fiddle with this until you get what you want. So there's just one thing left to do here, and that's to get our finished surfaces and or meshes into Rhino. If you take a look here, you'll notice that you cannot select on the Grasshopper surface when you're in Rhino, and that's because it's Grasshopper is keeping this as a sort of parametric surface. It wants to be able to update it all the time, so it's keeping it in Grasshopper. There is a tool for getting it from Grasshopper and into Rhino, and that's called baking it. And the way you do that is by right-clicking on the component that you want to bake. So you might not want everything to go into Rhino, so I'm just going to click the surface grid. I'm going to click bake, and then it is asking me which layer to put it on. So maybe I would click surface 1 here, and then say OK. And that's going to send it into Rhino. I happen to have the surface 1 layer turned off, so I'm going to bring up my layer palette. I can turn on the surface, and as you know, I already had one in there, so now I've got 2. So I can go ahead and just delete one. So baking allows you to go from Grasshopper back into Rhino. One thing to note though is that now that I've baked it back into Rhino, this surface, which I've got selected here, is no longer parametric. So any updates that happen in Grasshopper would not be reflected in this surface. So if similar to what I just did, if I made an update to this surface, I would want to delete this one and then go ahead and rebake the new surface in. So before we finish, I'm just going to go ahead and zoom out on the Grasshopper file. So you can take a closer look. Again though, if you want to sort of analyze this, maybe the PNG is a better way to look at it, which gives you a sort of annotated version with a bit of instruction next to each component. Okay, so that is making a smooth NURBS surface from 3D elevated contours. Hope that was helpful. Thank you.